Okay, guys. Good morning or good afternoon, everyone from different countries. Okay, my name is Hoshang. I am from Liverpool, Jammu, and I am working on augmented and virtual reality. I think if you can kindly mute the microphone, will be great. Yes, thank you. So let me introduce myself by presenting my research area. My background is mathematics and computer graphics. I started my PhD in computer graphics when I met the supervisor to ask me to add shadow for this environment that he provided as a driving simulator. He asked me to add shadow for this, and I started working on shadows. At the beginning, I started with the very basic concept of shadow to create shadow for a single pixel. This is light source. This is the shadow receiver to receive shadow for that pixel. Then I extended to create shadow for object on a flat surface and extended to shadow on other objects. Using a technique, we call it as a volume shadow, which is really costly when you want to apply it in outdoor environment for that driving simulator. So I moved to another technique called shadow mapping. In shadow mapping, we have two types of rendering. When whatever can be seen from the camera and cannot be seen from the light source is called shadow. This part is shadow. I created shadow based on that and presented a new shadow algorithm called shadow mapping, hybrid shadow mapping. This is the result of my shadow comparable with all existing algorithm at that time. Then for outdoor rendering, I try to create a sky color in real time. I propose this formula. This is my one of my objectives for my PhD. I propose this formula to create a sky color for each pixel of the sky in real time based on the location, longitude, and latitude using Paris model in physics. It means that I develop this environment. You can set location, longitude, latitude, time, and then see the sky color at that location that you just set it. And when you can change the time. For example, if you can see the down one, this is Eiffel Tower. At the specific time, we set the environment. You can see the sky color, the yellow and the white one and the yellow one and blue one. It is synchronized with the real one. But remember, this is a real time, not Photoshop or something like that. So let me show a short video of it is a start doing that you can see the shadow positioning, the shadow on the object, the sky is changing when the time is passing during the day. Okay. As we don't have time, I will not show all of them. Then when I had sky color and object, then I try to exert the effect of a sky on the object. In the morning and evening, the object must look like a little bit yellowish, rather at noon when the sky is blue and white. And then I use augmented reality to have a virtual object on real environment. This is real, everything is real. Based on this marker, virtual object is added here. Let me show a short video of this as well. When the sky is like that, yellowish, you can see the effect of that on my object. And we can increase the rate of convergence to see which amount of energy of the sky should be exerted on the virtual object. Now you can see the object looks a little bit yellowish. So we will change the time. Here I can change the time, location, and longitude and see the sky is changing. Now the sky is blue. on Y. So the object must look like more bluish and white compared with the previous one. You can see now changing the rate of convergence, and you can see the amount of energy of the sky affected on the virtual. Okay. Then I applied augmented reality. I had shadow. I used my shadow for augmented reality, and you can see my shadow. This is a real environment, as you can see my mouse, I think, on the left side. On the right side, you can see some virtual object, 2 elephants and a tree with the shadow. Shadow is created based on the real sky color and real sun position. When the sky is a little bit yellowish in the morning, see the effect of a sun on the real wall. My object, virtual object, looks like them. Follow that one. When on the right side, you can see when the sky is bright, virtual object looks brighter. After this, I try to add shadow for virtual object on real time. Here is the real environment. You can see real environment. This object is virtual, but the shadow of this is affected on the real wall. It means virtual shadow on real wall. And down, the picture on down, you can see the character is a virtual character, but everything else is real. You can see the virtual shadow on real environment. Now I can show a short video of this as well. Here everything is real except this character and the shadow of that. See real shadow, virtual shadow on real object. Even virtual character can walk on real environment. See going up, that's real. Because that environment is reconstructed using the camera. And we put it in the same place, registered in the same place, and you can see virtual shadow on real. When we move the environment, see now I will try to move out of the environment, and you will see the shadow how will be casted. Look at this part. See, at the same time, less than 0.8 milliseconds, the real whole environment is reconstructed. And now if the object moves, you can see the shadow is casted on still on real environment. Let's see here as well. You can see. Okay. Some more interaction. I did some more interaction. For example, see some of them. Here you can see how we show the effect of wind and blowing on the virtual environment, augmented reality. This is the marker, and you can see the effect of this movement being on that tree, even blowing. And also with the hand recognition, when I move my hand, you can see on computer the object is moving. I put one here to be using for you. Okay. Another project we did is Wi-Fi AR, which we can connect to augmented reality from different devices from different places. We also work on EEG signal, brain signal, to extract the brain signal and apply it in different environments. For example, the emotion of human emotion on virtual character. Authentication using BCI. We can just get the signal from the brain and find out is it related to you or someone else. Color detection, gamification for disabled people, reading mind using BCI, and now we are working on reading animal minds using BCI. Let me show you a short video of one of this. Here we extract the emotion of human and apply it in 3D character. When we are happy, the object must walk happily. When you are sad, the human is sad, that one will walk sad. We apply this on the facial animation as well. The people is happy and see in 3D character. Now, but the main issue with this is human must be really happy, not pretend to be happy. One more project we did for the Prime Minister of Malaysia, and we presented to create a augmented reality for his late father, who was the Prime Minister and legend of Malaysia. One more project, we did lots of projects on medical AR, and you can see this example to see. We extracted the heartbeat and applied in virtual character on augmented reality, and you can see how the heart is beating, and even each part of currently we are working on the different part of different muscle if it is not working there. And also we extracted and applied real skeleton on real body, but this is from virtual environment. It means the light of that exerted on the body, and we can see the movement of the skeleton. The one that we apply for facial animation, we extracted MPEG-4 data, then read the emotion of that human on that data and apply it on 3D character. Here you can see a short video of that.
When you are happy on the inside, the natural beauty will shine on the outside. With its sweet and beauty value, honesty, integrity.
As we don't have time, I will go. Another project we did is cloud simulation. We created our own physics to show the cloud movement in any specific movement and in dancing, and you can see a short video of that here. See how realistic is the movement of the cloud. Even you can see the shadow. Okay. We work more on augmented reality. One of the projects that we did is virtual heritage, to create a reconstruct a destroyed building. For example, this building was in Malaysia, we reconstructed in the UK, and here is the UK, here in Princess Park in UK. And you can see the shadow positioning, the effect of sky on the object. You can see the effect of sky on the object as well. We are working on animal-computer interaction as well, creative application for animal to interact with computer and use this technology. And also we work sometimes, I work on a virtual kiss, virtual hug, and virtual sex. I'm sorry, I cannot show a video of that, but you can just refer to this book or just check my name. You will find a paper that we published related to all good, bad, and ugly regarding to virtual sex. I found it not interesting and I left it, but we published one paper here. Now, let's see, comparing a little bit between AR and VR and discuss about this is some project that I have done so far and many others, but the one that related to AR and VR, I highlighted some of them based on my time. The augmented reality was presented in 1977 in a Star Wars movie, and now we have it. There are lots of devices available to see augmented and virtual reality. Here you can see a list of them that I have compared together: Oculus Rift, HTC Vive, PlayStation VR, Gear VR, and Google Cardboard. You can see the price of them. The price of them is here. And also the last one is HoloLens 1. We did some project with the HoloLens 1. HoloLens 1 is HoloLens 2 is the very advanced one. You can wear the device and enter to the augmented reality. Some of these devices, for example, Oculus Rift and HTC Vive, is for mostly virtual reality, rather augmented reality. And Google Cardboard, you can just put the mobile phone on that cardboard, which is 2 pounds, and the frame rate, or you can see the frame rate and the weight of them. Let's see the latest one. The very latest one, we can just say about Epson and Magic Leap, HoloLens 1 and HoloLens 2. You can see the main issue with this all is the field of view. Field of view is the amount of view that you can turn around your head. Here, for HoloLens 1 was 34 degree, but now is improved to 52 degree, and but the price is much higher. You can see the price, HoloLens is much higher compared with the other one. Magic Leap is one of them, which is really affordable, and but not all functionality that we have in HoloLens. Regarding the growth of VR user, you can see in 2014 was only 200,000 active user for VR, but now has been increased to 170 million, and the market size, you can also see the market size has been increased, especially 2020. And even if you want to compare AR and VR revenue projection, you will see here in 2016 and in 2021 expected to be like this, which you can see the augmented reality, the dark blue one, is almost 3 times compared with the virtual reality. Virtual reality, you know, is everything is virtual. When you wear the device, you will enter to the environment and you will see nothing about the real environment, but augmented reality, you can see both of them at the same time. The growth of VR industry, as you can see in 2015 was 129 million, while in 2018 become 5.2 billion, and the expectation is 45 billion by 2025. Now, the technology that is available for augmented and virtual augmented reality, let's discuss about the very old one, was too heavy and bulky. Currently is still something like HoloLens 1 and HoloLens 2, the more advanced one, but the problem still is heavy. When you wear the device and enter to the environment, you will see, you will get tired after 20 minutes, 30 minutes, and the field of view still has problem. 42 with the advanced one, the latest one that released, but still it is not that much. When you wear the device and see the environment, you only see 52 degree of freedom. You cannot go more up, down, or left, right. But in future, the expectation is to have a wide field of view in 3 more years to come, to have a good field of view like a virtual reality devices, to have a 110 degree of freedom. Retina display to have a high quality is expected to have in 5+ years. And we expect to have a contact lens to put in the eye and connect to augmented reality. You just wear the contact lens. The expectation is 10+ years, maybe 10 years, 12 years, or maybe more. And the neural implant, to implant the brain, it means that to connect the chip to the brain, as you can see here, some of the well-known companies, now they are working on this. You can see the Elon Musk from the Tesla company, they are working on this. And to connect chip to the brain, and then you can have augmented reality and many other things that we can have. When we could connect the chip to the brain, then we don't need to memorize everything. So in conclusion, I can say augmented and virtual reality still is a new technology, and you can get it involved in your current research. Whatever you are doing, you can use this technology to improve your current research. There are plenty number of projects that you can use this technology that engage your student with if you are teaching, if you are working in a company, create more project using augmented and virtual reality. And also, if you want for the publication, of course, if you get this technology involved, you can improve number of publication, and it is good to apply for bid. When you want to apply for different grant, different fund, it is good to use this technology. And as you can see in this picture, they are using Oculus Rift for animals to enhance the emotion. However, so far they couldn't make the cow happy, for example, the animal happy, but they could engage them to the virtual reality and virtual environment. This can be used in any researcher. This augmented and virtual reality can be used in any researcher for visualize your whatever you have, your data in 3D. So any related project, any related work that you have, I will be happy to collaborate and get together to do new project if you are working in different area, but you want to get augmented and virtual reality involved. Okay, that is all from me based on my time. Any question, please let me know. Feel free to ask me, or you can write it in a chat if you don't want to ask orally.
Hi, Kolivand.
Yes, there.
Okay, so my confusion is, what is the future you are seeing in the collaboration of AI with virtual reality or AI with augmented reality?
Sorry, the voice is reflecting future collaboration between augmented reality and
The future collaboration with artificial intelligence with virtual reality or AI with augmented reality.
Yes, yes. This is something really interesting, to use artificial intelligence, machine learning to predict, even to predict in augmented reality. We can use, as you know, in artificial intelligence and machine learning, we can train the system. We can use something like what you call it, artificial intelligence, as we say. But then use this technology, you use this technology to just predict. As I said, augmented and virtual reality is only for visualization. We cannot do something. We can do something using artificial intelligence, but we can use that and predict some of the future visualization in our data, whatever data we have. Yeah, there is a good link, and many people are working, especially, as I said, the Tesla company is still working on this to apply more artificial intelligence on augmented reality for coloring, for the size prediction, for the measuring the size, and some other things like this. I hope I answered your question.